It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other,
where you put your knowledge to test
and battle it out with a test
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. And here myself, Malesham Devasane. I'm taking the session for Discrete Mathematics, which is the second session in this on this channel for Discrete Mathematics, where I take the classes for theory of computation, compiler design, also C programming. Now we are going to see today the second part of the set theory. So before taking the session, as usual, let's talk about what we have learned yesterday in previous session. That is, we have learned the set definition and also types of sets and some of the operations that we have learned how to apply on the set, and where Cartesian product and subset are very important to talk about the relation function, group theory and lattice theory. So we have also looked at the subset as well as Cartesian product. Now using that, we have also learned the definition of a relation along with some of the types of relations, like what is identity relation, what is reflexive relation, what is a symmetric relation, and we have left with some of the types of relations like asymmetric, antisymmetric, transitive, equivalence and partially ordered relation. So these relations we are going to study today. Along with that relations, we will also move to functions, group theory and lattice theory. It depends on the time. I'm going to cover the important concepts. Yeah. So this is the entire schedule. Tomorrow we will have a propositional and a predicate logic, and in the coming sessions we will see graph theory as well as the combinatorics. In case if you are not aware of the Unacademy batch, and the first batch which was started on 18th Jan. If you are preparing for GATE 2022, and it is the right time to take the subscription and start preparing for GATE, because it counts every day, because you have 10 years of the time, the GATE preparation will be same, and even you have 6 months of the time, you will have the GATE preparation time. GATE preparation will go same way. So better to be in advance, and now you have 1 year of time, and so that you can prepare very smoothly by joining this batch. And if you want to join, you may use my referral code DEVALIVE. And we have started this Sankalp batch to make you revision, to make you understanding of the important concepts, and we are doing the same, and almost we are covering every concept which is required and which is important. But it is true that I am not able to cover all concepts of the subject, but I am trying to cover all important concepts of the subject because of less time devoted for every subject. Which is going to finish by 31st January. So slightly schedule was changed for discrete mathematics. In case if you want to learn from me or from any educator on Unacademy, just visit unacademy.com/DevaGateCSE and use my referral code DEVALIVE to unlock the free plan. And in case if you are interested to take the subscription, and you can also use a referral code DEVALIVE to get 10% discount on Unacademy. If you are visiting Unacademy profile, you can find a lot of quizzes, all-in-one sessions, and special topics, and daily practice problems, and PYQ series on many subjects. In case if you are not using Unacademy learning app, you can go to Play Store and install it, so you can watch all the videos using your mobile. And if you are not aware of Unacademy subscriptions, we have two kinds of subscriptions, Plus and Iconic. And what is the difference between Plus and Iconic? Whatever the benefits are there in Plus, you will have in Iconic, but additionally you will have dedicated coach and one-to-one interaction with an educator, and you will learn a lot, and you will have guidance. That is the most important point in Iconic. But already Plus has most of the benefits required, like structured courses and live interactive classes. But when you are in dilemma, when you want a support, then Iconic is going to help you, where you will have push up or boost from the dedicated coach to prepare in right manner. So Iconic is also most suitable for those people who are not able to understand how you can cope up with all the concepts. Then you will have a guide to help you. Now, if you are interested taking a Plus subscription, suppose, then if you are going for 1.5 or 2 years, then you can see the price for 1 year after discount, because when you apply referral code, you will see the total price 27,225 after discount, and for 1.5 year 34,650, for 2 years 39,600. And similarly Iconic, you have many plans, among them 1 year, 2 year plans I am talking about, which are very popular. You can choose as per your need. We also have Unacademy Combat, and today the Jan 26 at 6 p.m. and in case you have not registered, this is a free combat, so please register. You may use referral code DEVALIVE, and you can see, you can compete and you can participate in this combat and to test your knowledge. So please visit Unacademy Combat and register using DEVALIVE referral code and participate today at 6 p.m. and look at your result. How did you perform? And also we have competitive programming batch, where you will get a coding knowledge by top educators who are, especially I'm going to show our educators. We have so many educators. Before that, let me talk about, we have very good plan for GATE as well as competitive programming. So this competitive programming is going to help you for placements as well as the specialized knowledge in particular programming areas. And if you wanted to go for the combined package, then for 1 year you will have 51,233 after applying the referral code, let's say DEVALIVE. And if you want to see the educators, you have top educators here who are going to help you, like Tanuj and Pulkit, and you have so many good educators who are best in their field, like they have very good experience in top-notch companies like Imanshu. Yeah. This is Lojit. Good morning. Vikas, good morning. Tarun, good morning. Arun, yeah, happy Republic Day to everyone. Sorry, I forgot it. Okay, Anvesha, good morning. Lakshya, good morning. Yes, Lakshya. Do you want only practice? Then I will do only practice. You will have. You are going to get practice on every topic. We are already planning that. Yes, Tejas, we will have a practice. Don't worry about recurrence relation. You will be having practice on them too. Yeah, Arnab, good morning. Happy Republic Day, yes. Arnab. Yeah. You are attending regular, right? Directly you can come to the channel, right? Yeah, we'll share. Because we will conduct. And guys, after this uncle batch, what we are going to do? We are going to make you practice on each and every topic. Then who are following this uncle batch, definitely you will be connected to the practice session too. Remember, so don't worry, if you have the question, please practice on your own, but we are going to bringing the marathon sessions, practice sessions on each and every topic of every subject too. Yeah, good morning Kuldeep. Yeah. Don't worry, keep working on each and every topic concept that you need to understand. Okay, so in previous session we have completed sets and relation. We are continuing today itself, today also. Yeah, today we will have a plan for relations, then functions, group theory and lattice theory. So as quickly as possible I am trying to complete them, but if you don't understand any topic, and go to the textbook or go to the other videos that we have in the playlist and watch them completely. Yeah, so asymmetric relation, this was the topic we have to begin. Even we have not completed yesterday, this was the topic. Yeah, what is asymmetric relation? Have you remembered previous ones? Identity relation, reflexive, symmetric. We have seen these three relations in previous session. And asymmetric relation is nothing but if you have, let's say, x comma y in relation, let's say R is asymmetric relation, then y comma x should not be in the relation. Tejas, I am talking about YouTube channel. Okay, what does that mean? Suppose I have taken, let's say, A is equal to A, B, C, and I want to find asymmetric relation. Then if you look at the matrix, What are you trying to talk about this 9 elements? Will they have 0 or 1? What are the choices you have? What are the choices you have? Yes. If you are applying A cross A subset, if x comma y inside the relation, y comma x should not be in the relation, so diagonals are definitely not present because they have symmetric itself. X comma y comma x itself. Right? If x comma y is there, y comma x also there for diagonals, so they should not present in any asymmetric relation. Right? No diagonal appears in asymmetric relation. And remaining, you have 2 choices, like let's see how many choices are there. X comma, not 2, 3 choices you will have. X comma y and y comma x I am talking about. And also I am applying x not equal y, because x equal y we understood. X not equal y. Tell me, if x comma y not present, y comma x not present, it's fine. It is possible. It is possible. Everybody, it is possible. So I can have 0, 0, both of them, and one is present, other is absent. Like you have 0, 1 or 1, 0. 0, 1 or 1, 0. But it is never happens, both 1 never happens, because if one element present, other symmetric should not present. Yes. Good morning, Pratiksha. Yeah. Clear, everybody? So how many choices, how many non-diagonal symmetric combinations you have? If you are looking for this, how many non-diagonal symmetric combinations? Because I want to find the number of asymmetric relations, right? First I am trying to write number of non-diagonal symmetric combinations. Anyhow, diagonals you don't have a choice. Non-diagonal elements are n square minus n, but symmetric combinations n square minus n by 2. That's a 3. That's a 3 exactly. 3 combinations only there here. 3 combinations. Everyone, each of this non-diagonal symmetric combination has 3 choices. They have 3 choices. So, number of asymmetric relations. Number of asymmetric relations on set with n elements. We'll have 3 power n square minus n by 2. And yes, correct, Arnab. Yeah, Shubham, today only we have to start group theory and lattice theory, but you know in less time what we can complete. Okay. Now onwards I am not going to compute a number of relations. If you want, you can compute, but I will write for antisymmetric, then remaining we'll just study. Yeah, just identify asymmetric relation. If A comma B present, B comma A should not. Here diagonals are present, right? So this is not asymmetric relation. R1 is not asymmetric because all diagonals are there. And A greater than B definitely will not satisfy B greater than A. So if A comma B is there, that means if A is greater than B, then definitely B is not greater than A. So if A comma B belongs to R, then B comma A definitely not in R, because A greater than B implies B is not greater than A. Yes, it is asymmetric. R2 only. R3, all diagonals only there. So definitely it is not asymmetric. Fine. Let's move to antisymmetric. We need to go very quickly. So please understand, we need to cover relations, functions, group theory, lattice theory today itself. So I'm going to work on this, but I don't know exactly can I complete or not, but I will try. Antisymmetric relation. Here it's just like asymmetric. If A comma B belongs to R and A not equal to B, then B comma A not in R, means diagonals we do not apply this condition. So now when we are applying to diagonals, diagonals may or may not present, right? Diagonals may or may not present. If you say A is equal to 1, 2, 3, now diagonals, previously we said all of them are absent. Now we say either 0 or 1. We don't apply this condition for diagonals. Already you know 3 power n square minus n by 2 because of symmetric combinations. Now you got diagonals, so multiply with 2 power n. This many antisymmetric relations. Okay, just like if you try to understand the relation, every asymmetric is antisymmetric. That's why 3 power n square minus n by 2, all relations also comes here. Okay, now find out. Here you can see now diagonals I can keep, and non-diagonals, if A less than B, definitely B is not less than A, so this is antisymmetric. And every asymmetric is already antisymmetric, and here diagonals, all of them are antisymmetric. Only diagonals are there in the R3. Come on, all are antisymmetric. Everyone, because of diagonals are optional. Come on, Kuldeep, all are antisymmetric. Okay, transitive relation. I'll just revise the definition. If A comma B, or I can use X comma Y, whatever it is. If X comma Y belongs to R and Y comma Z belongs to R, then X comma Z belongs to R. Right? Example, suppose I have A is equal to 1, 2, 3. Now find out transitive relations. Suppose R1 is equal to empty set. R2 is equal to 1 comma 1. R3 is equal to 1 comma 1, 1 comma 2. And R4 is equal to 1 comma 2, 2 comma 1. Find out who is a transitive relation. First one, empty set. Yes, because there is no x comma y comma z, no need to look at x comma z. Only one element, always transitive relation. If a relation has only one pair, it is always transitive, no doubt. And also, if a relation has two pairs, that means two elements, one of the element is diagonal, other is non-diagonal, that is always transitive, no matter what is given to you. Right? Because this diagonal is not going to create additional pair. the pair that will you have in the relation you will get again. And R4, yes, these two are non-diagonals. Two non-diagonals can create a transitive problem. So 1 comma 2, 2 comma 1, here 1 comma 1 is not present, even 2 comma 2 also possible. So both are not available. And here 1 comma 2, 2 comma 3, 1 comma 3. But here the problem is, most of the people, they are not good at identifying. I'll just tell you R5. How do you apply basically? I'm just giving you technique. 1 comma 2, 2 comma 3. सीधा तो दिख रहा था. So you answer it, but you should not do that way. Take 1 comma 2 as x comma y. Now look for y comma z. That is only possible here, y comma z here. So now you are looking for x comma z. That's also there. Is that fine? But after this, immediately plan. Assume this is x comma y. Now look at, is there any y comma z? Because sometimes it is possible y comma z might be there. 3 comma 1 might be there somewhere. Right? So look for y comma z. There is no y comma z, fine. Right? Assume this is also x comma y. And y comma z, 3 comma something is not there. That means it is the transitive relation. Everybody? So this is how you need to check the transitive relation. And don't blindly check, don't do random check, which is going to waste your time. So assume this is x comma y. And check for all y comma z in this relation. And assume this is x comma y. Assume this is x comma y. And always check for where is y comma z. If there are so many y comma z, take individually and verify. And this is the best technique for a transitive. Yeah, good morning, Sneha. So now R5, R4 anyhow not transitive. R5, is it transitive? Yes. You can also use the graph technique and so many. Right now we have less time, so repetition is the most important. Okay, now identify transitive relation. You need to do it like this, you know. Suppose A less than or equal B and B less than or equal C. Will you have A less than or equal C in this relation? Okay, everyone, A comma B present, B comma C present. Is it guaranteed A comma C present? Because A also less than or equal C. Yes, this is going to hold transitive. Everybody, it's going to hold transitive. And what about A greater than B? If it is A greater than B and B greater than C, is it guaranteed A greater than C? Yes, it is guaranteed. It is guaranteed. Transitive. Right. Diagonals, we never have a problem. R3 also. Diagonals will never have a problem in the transitive. Yeah, R1, R2, R3 are transitive. Even R2 is also transitive. Pratiksha. Yeah, all. Look at how did I check? I didn't look at elements, I looked at properties, condition. Equivalence relation. Okay, I'm not going to talk about remaining relations, you can work out. Equivalence relation should satisfy reflexive, symmetric and transitive. And if you look at example, find out who is equivalence. Is it reflexive? All diagonals are there? Yes. Is it symmetric? If A less than or equal to B, can you guarantee B less than or equal to A? No. So it's not symmetric. So don't go for equivalence. It is not equivalence. Now directly I can conclude not equivalence. Okay, what about this one? Not reflexive. Directly answer it. Not equivalence. No need to check remaining all. And you have only diagonals. It will satisfy reflexive even it satisfies symmetric, even it satisfies transitive. We just verified it. So it is equivalence. Yeah, only R3, yes. Only R3. Now, what is partially ordered relation? And if you want to understand lattice theory, this relation is very, very important for you. Those people who are not able to understand lattice theory, the reason might be you didn't understand partially ordered relation. It is reflexive, antisymmetric, that makes an order. That antisymmetric makes partial order, and transitive. Right, now let's look at the example. Is this reflexive? Previously this was not symmetric, but it is antisymmetric. Yes or no? If A less than B, definitely B is not less than A. Diagonals is allowed. It's also transitive. Just now we verified it. Because A less than or equal B, B less than or equal C. Indirectly A less than or equal C also present in the relation. So it is partially ordered relation. It's a partial order. And here reflexive fails. So definitely not partial order. And this one reflexive and antisymmetric because of diagonals. Only diagonals are there, and transitive. So it is also partial order. Yeah, let me know if I assume anything wrong, because sometimes it might happen because without writing we are trying to answer directly. Clear this point? This is a kind of exam pattern where relations will be given, you need to identify them. Yeah, R1 and R3 are partially ordered relation and R2 not. Okay, so before moving to the next topic, before moving to the group theory, functions, let me quickly revise functions, then we'll go for group theory quickly. And this is the batch which is the first one who are joined late to this class, and this is the first batch started on Unacademy. And if you are interested, please join, and you may use my referral code to take the subscription. Yeah, what is the function? And then we'll see types of functions, we'll see composition if the time permits. Okay, what is the definition of a function? And look at the difference between set, relation and a function. What is the difference is set is always has something in the brackets, but in relation, if anything is there, that must be within the pair, and you should relate something to something. In the relation, you will only have the pairs. You have to relate some element to some element. And in the function, also there is something x comma y only, but here every element of domain is covered exactly once. This restriction was not there in the relation. We are going to put a relation every element of domain. Here y also, y is anybody's fine. Every element of domain is covered in this pair. So now let's start the definition of a function. What is function? F is a function, let's say, from A to B. We may represent this way. Here, first point, F is a set, and that is subset of A cross B. F is a set only. And second, of course, F is a relation. F is a set, F is a relation. You can write relation. And for all A belongs to A, there exists to be, belongs to be such that f of A is equal to B. It means every element of domain, here A is the domain, B is the codomain. Every element of domain will have a mapping to the codomain element, but guarantee unique mapping. That means if you see f of A is equal to B1 and f of A is equal to B2, of course it's never be there. It implies then B1 and B2 must be same. It means uniqueness. A never maps to two different elements. A can map to only one element. So unique mapping, uniqueness. This is existence. And this is a relation. So if you want to say f is a function, it must be a relation and it should have the mapping for every element of domain, and that should be unique mapping. Yes, Arnab, you're right. If you have only diagonals, it satisfies symmetric and antisymmetric. If you have only diagonals, yes, Arnab. Everybody, this is a function definition. And basically when you look at a function, suppose you have a, b, 1, 2, 3 and a can map to 1, b can also map to 1. Is it a function or not? If you look at f, of course this is f from a to b. If you look at f, a map to 1 and b map to 1. If you observe here, did you see in general f can be anything like this. In general, every element of domain, is it appeared in exactly one pair or not? So if anybody asks how many elements in each function, how many elements in each function, that means how many mappings, that means what is the size of the function? I'm trying to ask that. Size of function, it's equal to size of domain, because number of pairs nothing but number of elements in the domain. Everybody, so this is the most important factor. Size of is equal to size of A. Yeah. Now here we are going to look at our different types of functions, because we need to move to group theory too. Yeah. And number of functions you can easily compute. If you want to compute number of functions, anybody, can you compute that? Number of functions? Assume this is a domain and codomain. Tell me, x1 has how many choices? N choices. x2, n choices. And everybody has n choices. You can map to anybody, but map to only one out of an exactly one, nc1. So each has n choices. So n you are going to multiply. Number of functions, I'm asking how many functions you can design. N multiply with n, how many times? M times, which is equal to n power m, which is same as size of codomain power size of domain. Yeah. Come on, Arnab, you are writing in reverse order. Don't remember m power and n power m. Remember that codomain size power domain size. So you will never confuse who is m and n. Codomain size power domain size. Okay. What is constant function? In case if all elements they are mapping to the same element, like just now I told you, let's say 1, 2, 3. You have codomain here, you have domain. All elements are mapping to the same element, like f you can say now exactly 1 only. No need to say f of a is 1, f of b is 1, f of c is 1. Directly you can say f is 1. Yes, that's called as constant function. And what is identity function? That is possible when domain and codomain will have exactly same elements like a, b, c, and a map to a, b map to b, c map to c, like f of x is equal to x. X can be a or b or c. For every element in domain, you will have f of x is equal to x. This identity function. What is injective function? What is injective function? Quick. What is injective function? Yeah, I have a very good example for that. Injection or injective function. A function is injective. It's just like you have P1, P2, P3 and I1, I2, I3. Okay, you can create an environment of hospital. Here patients are there, here injections are there. And can you give the same injection to the two people? Of course, function can happen, but injection, if the function is injective, can you give same injection to the two people? Is it possible? Right? We should not, right? So this injective function is going to say the same thing. If there are two different patients, then you should get two different injections. That's the concept. So every two patients in the hospital should have two different injections. So P2 I can give I3 and P3 I can give to I2. Right? Injections can be more or equal to patients, but injections never be less than the patients. Right? So this is called as injection. What is injective definition? Every two elements of codomain, every two elements of domain should have different mappings. Must have different mappings. Right? So this is the definition of injective mapping. Injective. Now that's over, and now we'll go for surjection. Surjection is every element of codomain. Now we are talking about codomain. Every element of codomain has at least one preimage. It means now we are going to apply on codomain. Just focus on codomain. Don't worry about domain. It's already a function. It's already a function. Now we are talking about codomain. If there are four elements here and everybody must have at least one, you can have two also. I don't care. So look at, nobody left alone in the codomain. At least one pre-image is there in the codomain. Right? So you may have any number of elements in domain. How do you map is your choice. I'm just talking about in codomain, at least one pre-image should be there when you look at the function. Yeah, Nishu, good morning. Clear this point? Okay, you may have anything here if you want it. I may have 5 elements. I might be did this. It's fine. So this is this is onto function, also called as surjection. Yes. What is projective function? You have so many definitions. You can say injective and surjective. A function is injective and surjective, or you can say f and f inverse are functions. F and f inverse are exist. Yeah. Wish you happy Republic Day. Yeah. Keep focusing on function and also learn compositions. Now I am moving to group theory because I need to cover group theory and lattice theory too. Yeah. So I have helped you, to understand these things. Yeah, composition, just I'm leaving it, but I'll give you a definition. See, f is a function from A to B, A to B, and G is a function from B to C. B to C. Now G of F, when you write something G of F, it means when you are applying to any element, first you will apply to F, then you will apply to G. Remember, it's right to left. So composition we will follow right to left. So first you need to apply F, then G. Here F of G may be meaningless. F of G sometimes may not be possible because the codomain of G may not match with the F domain. So here it's very important, the codomain of F will act as domain of G. Then only this composition is applicable. Everybody, so you should be very careful when you apply. When you are saying G of F is A to C, means first F we applied from A to B and G then applied from B to C. So indirectly we got from A to C. Yeah. Everyone? Similarly, look at this one. At this time, G and F. G is A to B and F is B to C. Which is applicable now? G of F you can't do. G of F you can't do if A, B, C are three different domains. F of G is applicable. First G you can do, that is A to C. Then F you can do, or F, no, not possible. A to B, right? Sorry. G is A to B and F is B to C. Clear? Now first you need to apply G. So when you write F of G of X, this is same as first you apply to G, then you apply to F. This should be first and this should be second. So you should be very careful when you are applying this composition, which order you are doing it. When somebody writing F of G of H, then you need to apply first H, then G, then F. You follow always right to left. Okay. Somebody is asking inverse function. Yeah, not studied inverse function. Okay. So before going to algebraic structures, well, let me talk about the inverse. Somebody is asking inverse function. Which functions will have an inverse that we are talking about? Bijective functions will have an inverse. Basically, what is the inverse function? Okay, let me help you. Suppose somebody writing f of x is equal to x. Let's say x is belongs to z. Then what is this function first before finding the inverse? Every element you take in integer, what do you get? Of course, only bijective functions have inverse functions, remember that. And 0, it will map to 0, it will map to quick. Oh, x belongs to z, that's fine, but it's very difficult now. Okay, let me do that. I'm just deleting this domain. Don't worry about domain now. 0 to multiply with 0 and minus 1, that's a minus 2, and minus 2 is minus 4, and 1 is what? 2, and 2 is 4, and 3 is 6, and 4 is 8. Here f is a mapping from, let's say, z to, what is that? 2z. Everybody, So codomain is not a Z here. You should be very careful what I am trying to speak. This is a codomain now. This is the domain. And what is F inverse? F inverse is every element of 2Z will map to Z. So whatever I have given here F, and F inverse is like this. Yeah. So how many of you understood the domain and codomain? That's very, very important. How do you look at inside the domain and codomain? Right. If you say that codomain is just Z, then definitely F inverse not exist. F inverse you can't apply here. Okay. Now every element of codomain I can find F inverse. Look at that. If I want to apply F inverse, anybody? What is the answer? F inverse of X. What do you get? X by 2. Now look at in the reverse order. Minus 4. How do you get the 2? This direction. Minus 4 by 2. Minus 2 by 2. 0 by 2, 0. 2 by 2. And 4 by 2. 6 by 2. 8 by 2. Yes. So this is the inverse function. When we say F and F inverse both exist, then that F is the bijective. Yes, Shubham. Yeah. Clear? Okay. Algebraic structures. And you know, this is one of the important topic in set theory where just give me a second. I have a class at 10. Let me reschedule to 10:30 so that I can be there till 10:30 on this YouTube channel. Okay. Just give me 1 second. I'll be back. Just give me. I'll reschedule the class and I'll come back. Okay. I'll be there. In 1 minute I'll be there. Or give me time. Just take a break for 1 minute. I'll be back here itself. Yeah. Okay. Are you ready? Yeah, now I don't have any limitation time. So definitely I'll complete. Yeah, closure. What is closure? And then I'm going to explain. And remember these few things, and after that you may require what is subgroup. If you want, you can learn about subgroup, but I'm going to revise this important 5 topics in this algebraic structures. And look at where to use basically these algebraic structures. When you are implementing any programming language, basically you deal with operators, right? Operators, precedence table, and all these concepts are derived from this algebraic structures. When you are using the plus, multiplication or any operator in programming, they must satisfy some of the properties, right? That properties are derived from these structures. Let's look at the first. What is closure? Is also called as groupoid. Is also called as groupoid. When you take any set, it might be closed or it might be not closed. Whichever is closed, that is called as closure. So we have 2 definitions now. In theory of computation, this is a very famous topic, closure properties. Closure properties, right? Some are closed, some are not closed. Now I am talking about closure. Closure called as operation. Another name, operation. But before dealing with this closed, let me tell you what is operation. See guys, when you are applying any operation, let's say addition, how many inputs required? If it is binary operator, I'm just taking binary. If it is unary, only 1 input. You have x, y and z. So operation is also a function. Is it a function or not? It is a function. So there is one set. Can you see that? Domain is A cross B. So x belongs to A, might be, and y might be belongs to B, and z is the result that might be belongs to C. So operation is nothing but a function. But that function is not simple A to B. You are going to apply some operation on the domain. If it is unary operation, yes, it looks like A to B. Sometimes operations can look like this when you are applying minus, unary minus. Sometimes you can give only x, the result is, let's say, z. There's a minus x basically, minus x. At this time, just you have x belongs to A and z is belongs to B. That's minus x is belongs to B. Right? Operation can be even unary operation. In that time, the domain could be a simple set. But the meaning is different. Operation, function, what is the difference? Function need not be operation, but operation is the function. If anybody want to relate like this, sets, all sets here, and then all relations are going to come inside the sets, and all functions are going to come inside the relations, because every function is the relation. Set of functions I am talking about. Here next, operations. Every operation is the function, but function need not be an operation, because operation and function, they have a closest meaning here. Everybody, so operators, all the operators that are derived from these operations only. Okay, everybody, the relation, if I am saying operation, it means it is a function, it is a relation, it is a set. All words I can use. Every operation is also a set. That means when somebody is implementing plus, it means many people they assume plus is just operator, but plus is operation, means it is a relation, it is a function, it is a set. That means plus is a set, guys. Plus is a set. How is going to be happening? Like 2, 3, you will get a 5. And 1, 5, you will get a 6. If you are applying for integers, minus 1, 2, minus 1 plus 2, you will get 1. It's plus is a set basically. Everybody, where you have domain and codomain mapping. So this is how we define the operation. Everybody, is basically a logic, is algorithm, is a program. I can theoretically say a lot of things about plus. Okay, now what is closure? Understood what is operation? So we are talking about operations. Which operation is closed, which is not closed? When you are applying operation, you should think about domain and codomain. Both of them are there. Okay, suppose I am just talking about n comma plus. Is it closed? If it is closed, you can say that set of natural numbers is closed under addition. Otherwise, I can say addition is closed for natural numbers or set of natural numbers. It's your choice. Set of naturals. Right. It means just you can represent like this. Okay, if you want to keep 0, it's your choice. Okay, I'm just using n0. Okay, if you want 0, you can keep. Okay, I'm just writing from 1. That's fine. Plus is closed. Okay, I can represent many ways. I can represent many ways, like x such that x belongs to n comma plus is closed. So in the exam you do not know how do they represent the same notation, same problem. Yeah, set of natural numbers is closed under addition. Then what is closed? I didn't explain what is closed. I didn't explain closed yet. What is closed? What is closure? Right? Anybody? What is closed? You look at natural numbers. Any natural number, this is n, and pick any two elements. Any x belongs to n, y belongs to n, not one. I am talking about every element. When you apply the plus, the result, whatever you get, z, is it always belongs to n? Is always belongs to n? Then we say closed. Every two elements of the nature set, take and do the addition, you will get the result is also inside the natural. Yeah. If you add two natural numbers, you will always get a natural number. So it is closed. We can say now natural set is closed under plus. So we can simply write n comma plus is closed. But we have another word which is not closed. What is not closed? When we say not closed, what is that? Example, n comma minus. N comma minus. It is not closed. But why? Is that every two elements? No. Don't apply every two now. Don't apply every two. If you have there exists x, at least one is fine. There exists x belongs to domain and there exists y belongs to domain, and when you apply operation, I'm applying for binary. If you are applying for unary, take only one element and the result, that is x minus y, that z, whatever you get, not in n. Is there any such example? Yeah, Rahul, happy Republic Day. Is there any such example? Yes, so many examples, not 1, 2, 3, so many. But don't look for belongs to n, belongs to n also possible. Look only for not belongs to n. Okay, just like you have taken 2, let's take 5. 2 minus 5 is what? Minus 3. 2 minus 5 is a minus 3, but that is not in n. That means this set is not closed under subtraction. Yeah. So can we practice now? Can we practice now? Look at n plus n minus z plus z minus and z multiplication, even n multiplication. Yeah, just quick review on this few operations. Even if you want, I can go for division also. Okay. Now 9, especially I am going for Q division, which is very interesting operation. Okay, let's look at the first one. This is a closed, and we have just seen that not closed. Okay, Z plus. Remember one thing, the relation is like this: n is subset Z and subset Q, and it is subset of a real set and subset of complex set. You know this, the relation between the famous sets, natural set, integer set, and rational set, real set, and complex set. They have the relation. When something is closed or natural, so blindly you can answer many things. Example, you said n comma plus is closed. Then blindly you can say Q plus is closed, Z plus is closed, and R plus is closed, and C plus is closed, because they are going to satisfy properties like this. So you can apply this concept, but don't apply this concept in TOC. Yeah, only for this sets I am talking about. Z plus, if n plus is closed, don't think always, yeah, Z minus, but sometimes it could be possible n minus is not closed, but Z minus could be, because 2 minus 5, you got a minus 3. Minus 3 is there in integer, so it has to be closed. Z minus is closed because negative numbers also there now. Multiplication, multiply 2 integers, you will get integer. Multiply 2 naturals, you will get a natural number. But division, natural number by natural number, no guarantee of natural number, so it is not closed. Integer by integer, no guarantee of integer. But rational numbers, you should be very careful. You have a 0 in the Q relational set because of 0, and any non-zero by 0 you get infinity, that is not a number, right? So that is the reason not closed. But when you delete the 0, rational number by rational number is always a rational if it is not a 0, so it is closed. Everybody, so this is very important factor. Once you identify or once you understand the closed, not closed, this is gonna be very easy. But first understand what is closed. Closed means every 2 you are trying to worry about. Not closed means, is there at least one example where that operation goes outside the domain? That's why TOC closure properties very few people understands, because all closure properties definitions derived from here. Yeah. Now let's go for the semigroup. Semigroup, it means you need to satisfy closure as well as associative. Suppose if I take associative word, let me talk about associative. Guys, whenever the words associative, commutative comes, remember some operators like, operators, plus, multiplication, and division, subtraction. Okay, remember these operations, famous operations. Of course, in TOC concatenation is there. In matrices also multiplication, addition, but I am talking about for this sets, natural set, real set, I am talking about. Okay, yeah, difference, subtraction. Now for this plus, some things are fixed already. Here it's always associative if this operation is closed, and this is also associative always. Associative, right? Left to right or right to left, both are same, then we say that operator satisfies associative. Everybody, good morning Sandeep. When we say associative, operator is associative. When we say if you have left to right and right to left, have the same answer. And division, you don't get the same answer, right? Always you don't get the same answer, so it is not associative. In general, I am talking about in general. I can make it associative for the division if I have only one element, like a set which has only one, then definitely 1 by 1, 1 by 1 by 1 by 1, you get a 1 only. Do left to right or right to left. Sometimes I can make them, but this is, I am talking about infinite sets like natural set, all of them. And in general, these properties are true for non-trivial cases. And this is also commutative. Means A plus B is same as B plus A. They don't require the set, the properties they holds maximum time. This is not commutative in general. In general. And iska identity. What is identity? Here ID is 0, here ID is 1. And for this ID not exist. These are the things you need to remember in this group theory, because if you can remember them, that's very easy when you look at addition multiplication. Because addition multiplication are so important in the world. Even in implementation of the computers also, we implement addition multiplication, right? Yeah. Now let's start. Now closure and associative. When somebody asks n comma plus, you already know it is closed. Now blindly you can say associative. Why? Because plus always associative. But if it is not closed, please don't go for associative. We don't require to check the semigroup. Associative, is it true? X plus y plus z is equal to x plus y plus z. Is it true that whether it is left to right or right to left associative? Yes. Any three elements, this is always true, so it is associative. So can we say semigroup? Yes, it is semigroup. Yeah. Did I do anything wrong? Sorry. ID is 1. Yeah, what I did. I was writing very quickly, so I did the mistake. Anyhow, ID is equal to 1. Yeah, thank you, Arnab. Right, you are right. Anyhow, I am going to cover it right. Everyone, now n comma multiplication is also semigroup. Because n comma multiplication is already closed. Now it is associative. Can I say semigroup? If it is not closed, please don't check associative. If it is not closed, like n comma minus, it is already not closed. And not closed means not a semigroup. Even though suppose associative, still it is not a semigroup. But anyhow, we know it is not associative also. Anyhow, not semigroup because it's already not closed. Clear? Okay, let's quickly complete the definitions one by one. Monoid. What is monoid? And n plus, always take here, when you take n, include 0, because in general a natural set begins from 1. But in discrete mathematics, especially natural set begins from 0. So to avoid the confusion between in general n and our n, so we put n 0. Means it is a natural set which includes 0. And comma plus. Don't ask me, sir, what happens for n plus? Basically, we don't do that, such things. We include 0, then we consider, because we know we need a 0 for addition. Okay, now the set includes 0. We know already it's a semigroup. Now who is the identity? What is, it's a closed already. It is associative. Now who is identity? In the natural set, who is the identity? Now ID is 0 because I kept 0 inside. Then what is the identity definition? What is identity definition? Identity is x plus this ID is equal to ID plus x is equal to x. and that box you need to find who is that here. That 0 we got, that first 0 is called as right identity because right side is there. The second 0 is called as, that is a left identity. Yeah, this is called as identity property. Yeah, you might be studying matrix multiplications also, right? Okay, it is, can I say monoid now? It is monoid. But if you take without 0, n comma plus, you say that 0 is not present, explicitly you say that, then it is not monoid. But in computer science, we always keep 0 inside the natural set, especially in this algebraic structures. So, be careful. Now similarly, let's go to the next one. Inverse, group. Now, what is inverse? Let's try first what is inverse. Let's say x inverse is y. Inverse of x is y. That means x and y are inverse to each other. Then what we require to satisfy? Without identity, inverse impossible. So if you have identity, there is a chance to have an inverse. Remember, if you have an identity, there is a chance to have an inverse. Like x, apply some operation with y, or y you apply with x, you should get identity. Then we say x and y are inverse to each other. Everybody, if and only if x, y, when you apply with any operation, you should get identity. Example, of course now you can't go for n plus, but I can go for z plus. N plus, you don't have an inverse, but z plus, you know this one is already closed and it is associative because plus is always associative, and identity is 0 here. We already have 0. Now inverse, what is element? If you take any x, what is x inverse? You take any x, what is y for that? Minus x is a y. Everybody, x inverse is a minus x. That means if you are applying plus, that y should be minus x because the result will become 0. X plus minus x and minus x plus x, which will be 0 because we know 0 is already identity. So any element you take, 200, minus 100, minus 1000, every element just you apply minus of the given element. So you will get the inverse of the given element. Everybody? So it is a group. Now I can say it is a group. It is group. We are going to practice just after this, but first learn the definition first. Everybody, if I ask n comma plus, is it a group? What is n plus? Your inverse minus x means if I give you 2, minus 2 not exist in the n. So we say just monoid. Of course include 0 to avoid the confusion. Monoid but not a group. Okay. And the important algebraic structure is abelian group. Additionally, you need to satisfy commutative. And I have seen the people, the inverse definition and commutative definition, they keep on confusing both. The reason behind, because they look similar but not same. When you are applying inverse, what you need? Identity. You need to check identity. You apply with some operation, you should get identity, then you say x and y are inverse to each other. And in commutative, look similar but not the same definition. In the commutative, x and y, any two elements, they don't need to be inverse. but its operation should be equal to y with x. So when you switch the operands, result should be same. Then we say commutative. Here don't speak x and y are inverse to each other. We don't check in the commutative. Everybody, so be clear, both look similar but not same. Everybody, we don't check x and y are inverse to each other or not in commutative. We only check x plus y, is it equal to y plus x, then that is commutative. Okay, now commutative I am going to apply. What is commutative? Suppose let's say who are groups, example Z plus, it's we know group. Now I am trying to apply, it's already a group. This is already a group. We already checked these properties. Now additionally, is it satisfying commutative? That I am checking. Yes, plus is, whole world knows it is commutative. So it is now Z comma plus is abelian group. Agree? Z comma plus is abelian group. Okay. So before going to any other, let's practice some of the questions. Now first one, n comma plus. Now you need to answer exactly what is it. First let's try on plus, then we'll go for something else. Okay, for plus just I am taking 0 because most of the people do not know natural set also can include 0. Complex set. And even I can write my own set like even set comma plus, odd set comma plus, and what else I can write? Prime set comma plus. Okay, find out. What is this? Yes, good point. Guys, do not confuse yourself. What is the relation? Okay, how do I answer now? Let's talk about let me do something for you. See, all closures, if you have closures, then we check for associative, then we get semigroup. Some closures are semigroups, some are not. Everybody? And after satisfying semigroup, we come to identity. If it is not a semigroup, we don't come to identity to say monoid. Some semigroups are monoid, some are not. All the algebraic structures, they satisfy these properties. And when you satisfy monoid, then we go for inverse. If inverse exists, then we come to the groups. All the groups are here. And once inverse exists, then we go for abelian groups. All abelian groups are in this. Okay, that I can write directly in box. Yeah, now tell me, if any set is abelian group, will it satisfy all of them or not? Obviously, because all abelian groups are groups, all groups are monoids, all monoids are semigroups, all semigroups are closures. Clear? I already told you that if I apply n with a minus, then definitely it is outside. It is outside. Even n, what else I can say? N comma division, that is also not closed, outside. And remaining all, they will be distributed here somewhere. Clear? Who was that? Jayesh. Is that clear? If any set is abelian, you can say group, you can say monoid, you can say semi-group, you can say closure, all will be satisfied because every abelian group is also present in other structures. Okay, now first one. First one, what is the answer? I'm waiting because we need to go for lattice theory after this. Of course, I'm going to spend the time today because tomorrow we need to start proposition predicate logic. No answer yet. What is this? Where it stands exactly? It is closure, right? It is closed. And it is also satisfying associative. Keep on going further. And identity also there. Identity also there. 0. And inverse not exist. So we failed inverse. Inverse fails. Inverse fails. So stop there. So it is monoid but not a group. But sometimes it might happen in the exam. They may not have, you may not see the monoid but not group. You might see monoid but commutative. Yes, it is commutative, even though it is not a abelian group. Right? So you should be very careful while answering the question. Even you know the all properties, but while answering, there might be given right option, monoid but commutative. Yes. And this one, now inverse exists and also commutative, so it is now abelian group. In the exam they may say monoid, yes, monoid, it is also semi-group, it is also group, everything is satisfied. Q plus, obviously abelian group. When Z plus is abelian, Q plus, R plus, C plus, no confusion at all. But only N plus was not abelian group. Clear? So 3, 4, 5 very easily you can answer. But sixth one, even set. What is even set? Assume even set nothing but it starts from 0. 0, 2, 4, 6, 8. Hey to hai na? Now take any two even numbers, do the addition. Will you get even number always? Yes, that means it is closed. And plus we know associative. And ID is 0 also there. But inverse, what is the 2 inverse? -2, but -2 is not there in the even set. Yeah, everybody? Yeah, come on, come on. Yeah. Yeah, -2, -4, I am not considering even set. So if you are assuming even, then it will be there. So I am not assuming. So just take positive numbers, including 0. Do not go for negative numbers. I am not including here. Okay. So now inverse not exist, because even odd we just take in naturals only. Fine. So it is monoid but not a group. That's why I have changed the problem. You are going for negative numbers. So in the problem itself I mentioned. Yeah. Laksha, I have changed the problem because you are going for negative even. So just take positive even numbers. And I don't know what kind of events you are thinking about. Monoid but not group. What about odd set? What about odd set? Closed. Odd number plus odd. Is it odd again? No, it's not closed at all. It even not comes under closure. Not closed means not satisfies anybody. Prime set, prime plus prime. Any guarantee of prime? Now don't say negative prime. Prime numbers we look at only positive side always. Yeah. It's also not closed. It's also not closed. Clear? Understand? Prime plus prime. Who is that? Semigroup. Which is semigroup? Please number and say the answer. Yeah. Clear? This is about a plus. Let's go for multiplication. Let's go for multiplication. Now I don't have a 0. Look at, whenever I need a 0 I take, whenever I don't need I don't take here. So Z comma multiplication. Here 0 not there in the natural set. Very important operation, multiplication. C means complex set. Okay, now we know it is closed and associative. ID exists, which is 1. 1 is there in all of them. So identity is there for all. After that, inverse not exist, because 2, if you want to do the inverse, then when you are multiplying, if you want to get 1, then this has to be 1 by 2, but 1 by 2 is not there in the natural, so it is not going to satisfy remaining properties. So just you have to say monoid but not a group. Shubham, I am not teaching to you only. I have to take care of everybody, right? Z multiplication. Now, do you have that 1 by 2 inside? No, right? It will be same answer again. It is also monoid but not group. Same answer again. Even here, inverse exists for every element except 0. Yes or no? Because if you ask 0 inverse, if you ask 2 inverse, I can say 1 by 2, because 2 into 1 by 2 is 1. But if you say 0 inverse, you can't say 1 by 0, because 1 by 0 is not a number, right? So except 0 you have inverse, but still you can't say, you can't apply inverse property to that structure. So it can't satisfy the group. Still it is monoid. Because of one element, it was not a group. But when you delete that, it will become a group, and also it will become abelian group, because commutative also satisfies. Everybody, when you delete the 0, now inverse exists and also commutative satisfies because of multiplication, and because of that, R minus 0, C minus 0 also abelian groups, but 0 is there everywhere in R and C in 5th and 7th, so answer will be similar to monoid but not group. I'm just answering this one, just answer monoid but not group. Okay. Yeah, Shubham, who said 7 minutes left? I'm going to take next half an hour. Okay, next, you understood, right? Multiplication. Now we have so many questions, interesting questions are there. Look at very interesting questions. Set of square matrices of n cross n, order n cross n. You are applying with, let's say, addition. Second problem, take the same multiplication. And third one, set of, okay, take the same again. Small change here, set of non-singular square matrices. At least know the definition of singular and non-singular, then you can answer it. And multiplication only I am going specially. Yeah. Find out, Pranav, find out. Set of square matrices. Normal matrices also, if they have the same order, definitely it is closed. Everybody closed. And you know, addition is associative. And who is the identity? Null matrix. ID is a null matrix. All elements are 0. And inverse, but over which numbers? Take over real numbers. I'm just taking over real numbers, over reals. Every element of the matrix is a real number, assume that. ID is equal 0. And now, anyone else? Do you have inverse? If you have something like 2, 3, 1, 0, who is its inverse? Who is its inverse? Just you need to do -2, -3, -1, 0. You will get 0, 0, 0, 0. Identity, this is ID. Everyone, inverse also exists. Commutative, oh my god, it is abelian group. It's abelian group. Come on, 1, 1. First one is abelian group. Second, okay, multiplication. Of course, you can multiply 2, you will get another matrix, no doubt. Closed. Associative. Yes, associative has no problem, but commutative will create a problem. It is associative. Now be careful here. AB need not be same as BA. Everybody knows that. Right? Here commutative fails. It's not a normal multiplication of two numbers. And ID. You know ID, you have I matrix. All diagonals are 1, remaining are 0. And inverse, when you apply inverse, fails. Why? Because singular matrices, their determinant can be 0, and singular matrices, they don't have the inverse. So because of that, the answer for this is a monoid, but not a group. And when you take non-singular square matrix, this will become a group, because inverse also exists now because it is a non-singular square matrix. But abelian group, no, because of commutative property. Not commutative fails. It's not abelian now. Not abelian because commutative fails. Yeah, these three are very famous examples for gate point of view. Yeah, guys, please like the session if anybody not liked it. Yeah. I hope you can practice now this algebraic structures, which is going to be easy if you apply carefully. Okay, let's move to subgroup use study based on existing lectures. Now let's move to the lattice theory. What is a poset? What is poset? And basically why this word we use in this lattice theory? And very less people know about poset. Partially ordered relation, right? Suppose you are writing there is a relation R on set A, where A is, let's say, 1, 2, 3. Okay, R on A. Let me write completely, otherwise there is a partially ordered relation. Let me write A comma A, A comma B, and A comma B. Do you know this is the partially ordered relation? Is it satisfying? This relation I have taken on A. This is R on A, where A is what? 1, 2, 3. A is, sorry, not 1, 2, 3. A comma B. A comma B. So this relation I have taken on set A. And this is reflexive because A comma A, B comma B both are there. It is antisymmetric. Why? Because whenever A comma B is there, B comma A is not there. That's good sign. But diagonals, we don't apply that concept. And it is transitive too. But this is called as partially ordered relation. But what we say poset? Poset we write just like A comma B is a set which is some ordering. It's enough to represent entire R. Look at this is a poset, partially ordered set. Here this is called as order. And these are elements of the set. Elements of set are ordered by less than or equal to. That means it's going to cover A less than or equal to A, B less than or equal to B, and A less than or equal to B. And all the three relations are covered without writing. Just say order name. Everybody? Yes, B comma A is not there. That's right. Everybody? Clearly you can understand the entire relation I can represent in very simple manner. I can just say it is a poset. Poset is just, you can say, a short representation of partially ordered relation. Everybody, when somebody writing a poset, yeah, knowledge corner, thank you, same to you. You can say that poset is a shorter representation of partially ordered relation. It saves a lot of time. Okay. Now simply I can just say A. Okay, I will say later on. Now I want to draw the ASA diagram. We use mostly ASA diagram to understand this poset. What is ASA diagram? Hope everybody understood what is poset. Elements of the set are ordered using partially ordered relation concept. Now what is ASA diagram? ASA diagram is representation of poset only. If I have an ASA diagram, you have poset, you have partially ordered relation. It's a representation of entire poset. Suppose you have a poset, let me write 1, 2, 4, 6, 8, 48. Suppose I have these elements, but let me keep more, little bit more. 1, 2, 3, 4. With, I'm going to keep the symbol that is a division. So they are going to give you one thing, what is order. Suppose somebody writes x by y, it means they say that x divides y. It means x comma y represents. And what is this ASA diagram? ASA diagram is nothing but a DAG, directed acyclic graph, but it is upward arrow diagram. We don't show the upward arrow. Jayesh, we will practice in marathon session, right? If you look at each and every concept, when will I do? I'm already taking more time, right? Yeah. We can discuss on subgroup, but in this session, in 2 hours, each and every concept covering is really difficult. I'm already saying the Sankal batch, we cover every important concept, but sometimes I need to ignore because of other things. Yeah, if you want subgroup, at the end we'll see again. Sublattice also there. I am not going to discuss that too. Sublattice. Fine. X divides Y. Now look at this. 1 is the element which can divide everybody, right? Yes or no? If you don't have a 1, then you should draw different way. I will show that also. It can divide everyone. Now look at which elements you should take the next level. Next level, 2 I am taking, 3 I am taking, because remaining all the elements definitely divided by either 2 or 3 only. Everybody, if you have a 5, 5 also I am going to take. Remember that. But 2, 3 is enough. 1 divides 2 and 1 divides 3. Actually that is upward arrow, but we don't show that. And 2 divides, now next 4 you have to take, don't take 8 because 4 can divide 8. Then take 6, and 4 and 6 no relation. So 2 can divide 4, 2 can divide 6 and 3 can divide 6. Next 8. 8 only divided by 4 and 6 can't divide that 8. Now 48 can divide it by 8 and 6. And this is as a diagram. And they may ask how many edges. How many edges? Then you need to answer properly. If you take unnecessary edges like transitive edges, here even though 2 divides 48, even though 2 comma 48 pair is there, this pair also exists, but we don't draw edge. This pair exists, but no edge required for this. No edge required because transitively you can find 2 related with 48, because 2 to 4, 4 to 8, 8 to 48, indirectly 2 to 48 is there. Everybody, how many edges are there? How many? 8. And sometimes it could be possible, they might give, I will tell you, they might give some relation, some as a diagram. Okay, A, B, C, D. This is as a diagram, no doubt. But they may ask how many elements are there in the relation. In relation, how many elements are there? All elements, all diagonal elements are there, no doubt about it, because every element is related itself, but we don't draw any edge. That is trivial. And another one, A comma B you can see, A comma C you can see, B comma D, but there is something it's not visible, that is A comma D. That is a transitive edge. And how many pairs are there? 8 pairs are there. So 3 edges can represent 8 pairs. So this is the advantage of as a diagram. By representing, by showing few things, I can relate so many comparisons, or I can relate so many things. Everyone? And this is very important in this lattice theory. And those people who do not understand as a diagram, and they will fail to understand lattice theory, no doubt. Is that clear? No need to, we never represent transitive edges. We never represent transitive pair. Because transitive pairs will be understood. We never represent transitive pair in as a diagram. Yeah, I hope one example I have given, you might understood the concept. Okay, now let's go to the elements. In the elements, when we are talking about a poset, as a diagram we always take fine. Now find out. Look at what is a minimal. When somebody is saying minimal means you don't have, before that let me speak something. When you have an edge, what we speak, A is a predecessor to B and also to itself. Assume that way. A is predecessor to A and B is the successor to itself, but mainly we are talking about A, and B is also successor to itself. Assume that, so that we can relate so many things now. Yes, loop also not taken, good point. And loop never be. Yes, we never represent transitive pair and diagonal. Now look at minimal means there is no predecessor. No predecessor. Then how do you read this diagram? Start from down and go up. If you look at A has no predecessor here. So here we call, here who is the minimal? Who is the minimal? A is the minimal. Here who is the minimal? That has no predecessor. Here 1 or 2. Both are minimals. And who is the minimal here? P. The element which has no predecessor is called as the minimal element. The element which has no predecessor. And maximal means no successor. Look at now, maximal. Don't say maximum, that is different. Here least, another name is minimum. Greatest is the maximum. You can use that words if you want. Okay, who is the maximal here? D, also E. And who is the maximal? The element which has no successor, 5 and 6, no successor. And here maximal T. Clear? But least means there is an element is a predecessor to all the elements of the diagram. So is there any element? Sometimes least may not exist. When it exists, it is the predecessor to all elements of the diagram. That is A. And who is the least here? Not exist. Not exist. Because if you say 1, then 1 cannot be least because 1 has no relation with the 2. And 2 you can't say because 2 has no relation with 1. Right? And if you look at last one, least is a P because P has the relation with everybody and P is the predecessor to every element of the diagram. So what is the least definition? When you say least, it is a predecessor to every element of the diagram. Least, I am writing somewhere to remember easily. Least means if it exists only 1, if not exists fine. Least element means it is a predecessor including itself. It is predecessor to entire set, entire poset. You can say entire poset means entire diagram. Greatest means it is a successor. Do you have any greatest? Also called as maximum. You can use the maximum word also. Do you have any greatest? No greatest. D and E, you don't have any relation between them. You can't say anybody greatest here. And here any greatest? 5 and 6, they don't have any relation. You can't say anybody is the greatest here. And the last one, the greatest element is T. Yeah. Please like the session if you have joined late. Okay, now we understood elements little bit. Now lower bounds, upper bounds. The most of the students they are going to face the difficulty here, because they assume lower bound directly comes from the lattice. No, it's not for the lattice. That's a different question. Mostly the questions might be asked lower bounds for a particular interest, the particular subset of the given set. Okay, what is that means? Let's look at one example needed. Yeah. You have this example. Now I may ask lower bounds for a particular subset. That subset I am going to take, let's say, okay, first let me explain lower bound only. Lower bounds of D comma C. Even I can ask more, E. This is a subset of the given set. Now what are the lower bounds? Lower bounds, nothing but there is an element which is predecessor to all of them. Like there should be an element X, it should be predecessor to this and predecessor to this, right? There is X which is predecessor to all the elements of DCE. That X might be there in the same set or it will be there in the actual set. Yeah, can you find out? DCE. C is a predecessor to all of them. But C is there inside, it's fine. Predecessor to DCE. And not only C, A also is a predecessor to all of them. Come on. Everyone, C is the predecessor to CDE because C has a relation with C and DE and A also has a relation with the CDE. So then we get answer C comma A. Yes. A is also right. Lower bound. Your interest only should happen here. And A is also lower bound to these three elements because A has the relation with all the elements of that set. Everybody? Yes, Pranav. A and C both are the lower bounds. Right? But C is there in the same set, A is there in given set. It's fine. It can present anywhere. But if I ask lower bounds, let's practice. If I ask LB, lower bounds of D comma E, what do you answer? Lower bounds of D comma E. Now my interest is changed. Now I am only looking at D comma E. Now my interest is changed. I am only looking at this. What are the lower bounds? That element should be predecessor to both of them, not one of them. Both of them you should take. Just don't look at one of them. Look at both of them. B, is it predecessor to both? No. C is predecessor to both. Yes. A is also predecessor to both. Right. C and A again. C and A again. If I take lower bounds of D comma F, then find out. Now my interest is changed to some other element. Now this time you need to look at, I changed my, now this one, look at these two elements. Who are the lower bounds to these two elements? Find the element which is predecessor to both. D comes out because D is the predecessor to both of them. E is not predecessor to D, so you can't take it. But C you can take, because C is predecessor to both D and F, and B also, A also. B, C, A, including D. We're missing D. Come on, come on. You should not miss the D. D itself is a predecessor to both. Fine. Now let's practice all of them together. Understood how to look at the lower bounds? Why people fail to answer? Because they don't look at what is given. Yes. Okay. Now we have lower bound and greatest lower bound. GLB also called as greatest lower bound. Greatest lower bound. Now let's take one example, then work out what is this exactly. Yeah. Okay, now my interest is first lower bounds. Lower bounds of some set I am giving, just look at B comma C. Find out the answer. Lower bound, I can ask for any set. Lower bounds for entire set, for entire poset. It's my interest. Okay, now first one. For B comma C, who are the lower bounds? A is the predecessor to both of them. But B you can't say, C you can't say, because they don't have relation. B comma C, where I am looking here? Sorry. I'm sorry guys. I am looking D and C. Okay. So B and C here. C and B, look at here. I am looking parallel. So CB, which is equal, B is, you can say, predecessor to B and C, and F is a predecessor to both B and C, and A is, you can't say, because A is not a predecessor to B. Yeah, BF is right. BF is right. Actually, my interest was something like this. Lower bounds of D comma C. I was written wrong. Fine. So, for D comma C, you will have A, you will have B, you will have F. Actually, I was about to write that. Clear how to find the lower bounds? It could be one or more, doesn't matter. Even sometimes you may not find, sometimes. For entire poset, F is only lower bound, because F is only the element which is predecessor to all of them. Clear everyone? Lower bounds. Everybody clear about lower bounds? Now the question is, what is the greatest lower bound? Greatest lower bound of, let's say, D comma C. For D comma C, who is the greatest lower bound? See, out of ABF, focus on only out of ABF. Do you have any greatest? How do you apply? You first find lower bound. First you focus on lower bound, then focus on second greatest. So if you find lower bound, you already know the answer. We did that. Greatest of A comma B comma F. But out of these three, no greatest. You don't have any greatest. Right? But who will have greatest? Look at this one. If I apply BF, in that B and F, B is the greatest, no doubt, because B comes after F. Everybody? So if I ask greatest lower bound of B comma C, then here you need to find first lower bound. First you find lower bound. You already did that. B comma F. I'm just writing greatest of B comma F. But among this B comma F, B is the greatest. Clear? Sometimes GLB exists, sometimes not. But only one will be there, GLB. More than one will not be there. Lower bounds can be many. but G will be either 0 or 1. Okay, now let's move to upper bounds. Upper bounds. Okay. Okay, now if I look at upper bounds of A comma E, what do you get? You will get E, because E is a successor. Now look at element which is successor to all of the given elements of the set. E itself, it's there in the set, also it is dominates everyone. And apart from this, B, C, D, everybody is a successor to A and E. Yeah. And if I want to find upper bound of B comma C, not exist, because B comma C there is no successor. It is not there in B and C. It is not there above also. And if you ask me upper bounds of particular element, everybody comes out here. If I ask upper bounds of A, just A I want, then what happens? A comes itself is upper bound, and E, B, C, D, everybody. If I ask upper bound for entire diagram, you don't have lower bound, you have upper bound of entire poset A, B, C, D, E, then you get nothing, not exist. But lower bound you have, A is the lower bound. Now what is this least upper bound? Let me ask, least upper bound. Least upper bound of, let's say, E comma A, that is A comma E. First thing you have calculated already. Here first again upper bound you calculate, that least means minimum of EA. You got already EBCD, so I am just directly taking it ABCD. Who is the minimum of this EBCD? Among them, who is the least upper bound? Come on. Who is the least among them? EBCD. If you compare these four elements, who is the least element? And that is also inside that four elements. That is E. That is E. E is going to predecessor to all of them. Least among only those four. Remember, never go out of them. अरे you can take anything. अर्नब, आपका डाउट मुझे भी आता है. अपर बाउंड कुछ भी पूछो ना, आप जो चाहिए वो ले लो ना यार. मैं तो रैंडमली पूछ रहा हूँ क्वेश्चंस. अपर बाउंड आपको क्या करना था? बीसीडी कर लो, उसी को कर लो ना. क्यों पूछ रहा है? बीसीडी करो. नहीं है ना, नॉट एग्जिस्ट ना, होगा तो लिखेंगे हम. यू डोंट हैव अपर बाउंड फॉर बीसीडी. लिखो जो चाहिए, 1 एलिमेंट लिखो, 2 एलिमेंट, 3 एलिमेंट, 4 एलिमेंट, 5 एलिमेंट तक कुछ भी लिखो, बिकॉज दैट मेनी सबसेट्स आर देयर. वी आर फाइंडिंग अपर बाउंड्स फॉर द सबसेट्स. कम ऑन अर्नब, कुछ भी पूछो ना. एनी सबसेट यू आस्क मी, I can find upper bound if you have any. Everybody understood? No restriction which subset you want to take. In the exam, they could ask for any subset. You must look at carefully. That means you need to find the successor in the diagram that is going to dominate all the given elements. Okay. Now what is lattice? अब तक जो पढ़ा रहा है ना, ये लैटिस के बारे में, लैटिस समझने के लिए ये सारे काम कर रहा था हम. A lattice basically a poset. It is a poset, but every 2 elements, ये ना इतना सारे कर रहा है ना. You are doing 2 elements, 3 elements, 5 elements, 1 element. ये नहीं करेंगे लैटिस में. every two elements must contain least upper bound and greatest lower bound. Everybody, every two elements must contain LUB and GLB. It means if we have a name here, LUB, least upper bound, LUB also called as least upper bound is also called as binary operation. Binary operation here, but not in the previous. In the previous concept it was not binary. Here in lattice, LUB is also called as binary operation. That name we have given as, here LUB is called as join. So join you can represent with a symbol or, of course, that's a join symbol. Greatest lower bound is called as a meet. That symbol you can represent with like, conjunction symbol. These two are binary operators because you can apply. Pranav, मैं तो अभी start कर रहा है ना join and meet. I'm just started now. I'm explaining join and meet. Pranav. Then you are asking the same thing, right? What is join? Join nothing but least upper bound. But you will apply only for two elements. For two elements, we compute least upper bound. And meet again same. For two elements only we will apply, not three elements, four elements. Because lattice definition depends on every two elements. For every two elements we compute greatest lower bound. How to look at? Meet means look down, join means look up. Basically upper bounds are there above and lower bounds are there below. So meet, whenever I talk about meet, look down. But let's find out, let's practice. Let's practice if you are not good at finding them. Okay, suppose I am giving something. A, B, C, D, E, F. But basically you don't do this in the exam. You should know what is not a lattice, because what is a lattice? It's very difficult to verify. A, R, B and A. Here A join B, A meet B. Finding everything is difficult here. Finding everything is difficult here. Are you going to do all of them? Are you going to do all of them? It's going to take much time. If you want to prove a lattice, it's going to take much time. Everybody, but let's find a few of them. I will tell you how to do that. A, B, join means first find out A, B for these two elements, which is least upper bound. Upper bounds, so many. It's just LUB of A comma B only I am asking. Just for two elements. First you need to find least upper bounds of A comma B. What are the upper bounds of A comma B? B, E, F. Least of B comma E comma F. Who is the least among B, E, F? Just B. Everybody, is it clear how to come up with the join? Not easy. Join is not easy. Meet is not easy because you don't get directly. First you need to look at up and you need to look at down again. Everybody, okay, next meet. When you are applying a meet, that's the greatest lower bound. Look down. It means G is the greatest and lower bound of A comma B. Who is the lower bound of A comma B? Just A. So greatest among A is just A. Clear this point? And in general, computing this join and meet for every two elements, it takes a lot of time. So we never do that. Instead, we will know that what is not a lattice. That's more easier than what is lattice. Okay, we are going to practice that, identifying lattices. Okay, before this, sorry guys, something is happening, just wait. Yeah, so before going to the types of lattices, I just want to find out which of them are not lattices. You know, first one, look at this example. Look at this example. Why this is gonna be not a lattice? Because this is not a lattice. The reason is, when you look at B and C, if you take B and C, for BC, when you go for upper bound, can you find them? Means join upper bound and least upper bound. So B join C. Everybody? Come on. So there is no least upper bound. There is no least upper bound. There is no this is LUB of B comma C not exist. As a lattice, you know, every two elements should have a join and meet. So you fail join. Join of B and C is missing. This is the reason. They might ask in the exam, what is the reason to be a not lattice? Then you should answer B comma C is the reason. Second example. Now I may have a diagram like this, 1, 2, 3. Now here the reason is 2 and 3, they don't have a meet, they have a join. The meet not exist for 2 and 3. That is greatest lower bound of 2 comma 3 not exist. This is also not lattice. Not lattice can happen many ways. And third one, when you have something, you know, like, of course I'm trying something different way, it's fine. Okay, A, B, C, D, and look at from down to up only. If you look at AB, is that 2, 1 and 2 are mixed here, right? And for AB, for A and B, what not exist? Meet not exist. Look down. Meet means find the lower bound and find the greatest among them. But lower bounds are not there. So meet not exist. And for D and C, join not exist. But remaining exist, guys. For D and C, oh my god, meet also not exist. For D and C, meet also not exist. Why? Because lower bounds are A and B, and among them you don't have any greatest. And for A and B, meet not exist, and also join also not exist. So many reasons here. So many reasons, guys. Look at now. For A and B. Wait guys, again something is happening. Okay. For A and B, when I try to find join of A comma B, it's nothing but least upper bound. Upper bounds for A comma B is D and C. Both are there. But D comma C, there is no least not exist, because D and C both are not related. You can't find the least among D and C. So join also not exist. Yeah, you can remember the structure of the acid diagram which are not lattices. So in the exam you can apply them. Fourth one. Yeah, you can look at, you know, mixing the concept. I'm mixing them. A, B, C, D, E. Now you can say that A and B meet not exist. Meet for A and B is missing. Join for D and E is missing. Join means look up. Both are not exist. Why? It is not a lattice. Not lattice is always easy rather than lattice. So if you know which are not lattices, which will become so easy to identify a lattice. Because your focus is on, are there any two elements, their join or meet not possible. Clear? This is one of the gate question where most of the students, they did not know how to identify it. So identifying not lattice is always easy. So please work on this. Okay, finite lattice. I have so many examples but I can't give now. Finite lattice. It is a lattice which has finite number of elements. Which has finite number of elements. इसका मतलब you may also have infinite elements. That is next one. It is also a lattice which has infinite number of elements. It is possible to represent infinite number of elements. How is that possible? Just look at it quickly. You know, when somebody drawing this is a lattice. Every two elements you will find, meet and join. So this is a lattice, but it is a finite. But when somebody writing for n comma less than or equal to, then you may start from 1, then next 2, next 3, and this never ends. This never ends. This is infinite lattice. Means we can draw two kinds of, so many finite lattices. Even we have drawn something like this. This is also finite lattice. This is also finite lattice. Every two elements will find, meet and join. Clear? Hey Pranav, LUV GLV should exist for every two elements यार Pranav. क्या पढ़ रहा है डेफिनेशन? एक्सट्रीम पॉइंट्स क्या वहां पे नहीं मिल रहा था. वी शुड ट्राई फॉर एवरी टू बट यू कांट बिकॉज ऑफ इट टेक्स टाइम. सो आई एम डिसप्रूविंग इट इज नॉट अ लैटिस. आई एम प्रूविंग इट इज नॉट अ लैटिस, है ना. बिकॉज अगर लैटिस बोलना है ना, यू हैव टू ट्राई. ए बी के लिए है क्या, ए सी के लिए है क्या, बी सी के लिए है क्या, ये सारे चेक करना है आपको. मीट जॉइन टाइम लगेगा ना, राइट. Okay, everybody got finite lattice? You have so many examples. This is the finite lattice. Now I am not giving the names. All these are famous structures in lattice theory. These all are lattices and they are finite lattices. Okay, such examples are so many. And infinite lattices. What are infinite lattices? Just now I told n comma less than or equal to, which looks like this way. 1, 2, 3, 4 and 5 and so on. There is another one, n greater than or equal to, where you may have now you have 1, 2, 3, 4. You ask any two elements, I will have meet and join, but never ask for entire diagram. Entire diagram don't ask LUB and GLB, right? You don't have, but we never try for entire. We try only for two elements. Ask me any two elements. If you ask meet, what I do, meet means 3 comma 2, let's say 2 will be, meet means minimum, just find minimum. If you ask me join, just take maximum. Answer is over. Here meet means 3 comma 4 suppose, or 2 comma 4. 2 comma 4 meet is 4. Meet here, meet is maximum. Here join is minimum, because you need to go up now. Everyone, so infinite lattices also possible. Infinite lattice is also possible. Now bounded lattice. What is bounded lattice? If you look at this diagram, A, B, C, D. For entire diagram, do you have a bound? Yes, this D is called as upper bound of entire lattice. I'm not talking about any two elements, entire lattice. This is a lower bound of entire lattice. If you have them, then that lattice is called as bounded lattice. Bounded lattice. Bounded lattice. Is there any lattice which do not have the bound? Yes. Like n less than or equal to, n less than or equal to infinite lattice. Did you see that? Infinite lattice. This is bounded lattice, first one, but second one is not bounded. It is a lattice but not bounded, because entire lattice there is no upper bound. There is no upper bound for entire lattice. Similarly, n comma greater than or equal to also you don't have lower bound, not bounded lattice. Then what is a bounded lattice? It is a lattice where lower bound and upper bound exist for entire lattice. Very simple definition. It is a lattice where I'm not going to check two elements. Two elements already we checked it because the lattice, where entire lattice has both lower bound and upper bound. Lower bound, upper bound. And you may thinking about, sir, infinite lattices will never have lower bound, upper bound. Wrong. It could be possible. How? Sometimes if I want, let's say 0 and 1, I'm representing real numbers. Right here, I'm just going to represent, let's say 0.1. And this side, let's say 0.01. Here so many elements are there. And this side, let's say 0.2, and infinite elements are there. You know that in between 0 1 infinite elements I kept in between. Now this is bounded because this is the upper bound. Every two elements you ask for this real numbers between 0 and 1, I will definitely have meet and join, and also I have lower bound and upper bound for entire lattice. So this is lattice as well as bounded lattice. Yes, very good point. Finite lattice is always bounded, no doubt. Finite lattice always bounded, exactly. But bounded need not be finite. Bounded need not be finite. Bounded sometimes can be infinite. Need not be finite lattice. Good point. Everybody keep these points. Okay, everybody clear about bounded? Then why people compute bounded? Because of there is next lattice is complemented. If the lattice is not bounded, it's impossible to compute complemented, because complemented lattice, it is bounded. Only bounded lattices are eligible to compute the complements. इनको डाउट आया, ये रियल लाइफ में लैटिसेस कहाँ यूज होता? हाउ मेनी ऑफ यू नो द प्रोग्राम एनालिसिस? सपोज यू आर राइटिंग x is equal to, and let's say y is equal to x plus a, and actually what are you doing? You are writing the statements, but you can make the diagram. You know, after x is equal to, you will go to y is equal to, let's say this is A, this is B, and I'm just traveling, you know, meet and join, you know, A and B, and actually, you know, after this, if I check any condition, I may go to C or D. So what is this program points? And basically this lattice is going to help you in program analysis. Then why do you need to analyze the program? Because if you know the code optimization or code generation in code optimization in compilers, if you know that, basically you need program analysis for control flow and data flow, basically data flow analysis of the compiler uses this lattice theory. Best example where it is going to understand which statements are going to be a meeting and joining. Yes, everybody, this is the practical example where the lattice is actually theory which will helps to build the code optimization techniques. Yeah, everybody, it's actually a program, but we build a lattice for this program. I've just shown you two statements, but program can have any statement. For a whole program you can build a lattice. For a program you can build a lattice to understand the meeting point, joining points and relation between the statements. A program can be converted to lattice to understand the data flow. Yeah, so don't worry much about it. This is the best example that you have. It is bounded lattice and every element of lattice should have at least one complement. Every element of lattice must contain at least one complement. That means complement exists for every element. At least one complement. Every element has at least one complement. Everyone? So example, A, B, C, D, E. This is one of the gate question. Now first identify upper bound, lower bound. Without them you can't compute the complements. Then what is the complement? First you should know the complement. Suppose X complement is Y. X complement is Y. Or X and Y are complement to each other. Then how do you say that? X and Y are complement to each other. Quick. Come on. X and Y are complement each other. Here, join when we do, it must go to the, remember that, it must go to the upper bound of lattice. If it is not going, then they are not complement. And not only that, meet when we do, they must go to lower bound of lattice. If not going, then they are not complement. Everybody, what is identity yaar Arnab? Yeah, identity nahi aata yaar. Ye inverse, we are not finding inverse. Inverse alag hai, complement alag hai. Inverse was in group theory, complement is in the lattice theory. Come on, look kahan se yaar. So please like the session if you are watching this video. Clear this point? पहले इसको समझ लेना. If two elements are complement each other, to join should go to upper bound, to meet should go to lower bound. Meet and join need not be same. Why same? Join you will go up, meet you will go down. Come on, Jyoti Singh. They don't say same. Join should go to upper bound. Now let's look at A का complement चाहिए. I want to find A complement. Why do I say E? Because A and E, इसका meet is A, join is A. That blue boxes must be your answers. Everybody, here look at join of A comma E. Did you get a blue box? That's upper bound. Upper bound of lattice, वो तो फिक्स है. Upper bound कोई चेंज नहीं कर सकता, है ना? And meet of A comma E is lower bound or not? Yes, you have to reach them, otherwise they are not complement to each other. Yeah, Batman, Happy Republic Day. And what is B complement? C भी हो सकता, क्यों? B C का join upper bound, BC का meet lower bound. Speak upper bound, lower bound. No need to speak E and A. You can think about that. And why do I say D? B complement can be D. Why? Because BD, join is the upper bound, meet is lower bound. And why not A? Why not A? Because B and A, when you take meet, it's working fine, but join is B, not upper bound. We are not able to reach E. So B complement is not A, because B and A, when you join, you are getting a B. We are not getting E. Clear? And C complement, similarly you can easily answer B comma D. D complement, B comma C, but E complement, that is A. And every element has at least one complement, then it is the complemented lattice. It is complemented lattice. ऐसा कोई एग्जाम्पल है क्या वो कॉम्प्लीमेंटेड लैटिस नहीं हो सकता? लेट्स ट्राई. First, is it a lattice? Is it a lattice? Yes, it is a lattice. Is it bounded lattice? How do you know bounded? Because these are called as bonds. It is the lower bond, it is the upper bond. They are going to help you to find the complements too. And is it complemented? Now you have to find what is, do you have A complement? Do you have a B complement? Do you have a C complement? D complement? अगर किसी को नहीं मिले तो it is not a complemented. You can have more than one if you want. A complement क्या होगा? F होगा. क्यों? A and F join is upper bond, meet is lower bond. And B, and you try everyone, then only will understand. B complement, assume A, assume C, assume E, assume D, but I am going directly because of lack of time. B complement. अब क्या होगा? B complement क्या होगा guys? Suppose anybody says C, गलत होगा. क्यों? Join of B comma C. Join of B comma C. Join means least upper bound. Least upper bound of B comma C means first you find upper bound. Upper bound of B comma C, you will get D and E and also F. But there is no least. There is no least among a DEF. That means BC के लिए join exist नहीं है. Right? Then is it a lattice? I'm very sorry, it was not a lattice. I was assuming it because of intersection. Now we never go to the computation. Have you seen the cross section? Did I give an example? That structure is here. So it is not a bounded lattice also. Even though lower bound, upper bound exist, but it is not a lattice, so it is not even bounded lattice. Because not a lattice first. I'm very sorry, but you know, I need to change the concept now. Now I'm going for something. Yeah. Now look at. Now it is a lattice. Yeah, sometimes it happens when we take examples, but that was also a good example. It was not a lattice. Now check B and C. Do you have a joint meet? Yes, you have. You have every two elements now. This is a lattice. This is a lattice. And it is also bonded lattice. But now you need to check complement. A complement is F, now true, but B complement. Do you have any B complement? Suppose if you assume C, now what do you get? Join. D is the join. D is join. D and F both are upper bounds. Least upper bound is a D. So we are not going to the upper bound. We are not going to the F. So you are not getting F when we do B and C join. So C cannot be complement of B. And E, B and E check. B and E, is it possible? B and E. Yes, B complement, is it E? B and E. B complement E, check it. Join of B comma E. Are you going to F? Yes. Meet, are you coming to A? Yes. So you got it. The B complement is E. Now C complement. C complement. C complement. Ab hota. There is no complement for C. Why? C complement, try A. Fails. C complement B, try CB. Meet is right, but join is D, wrong. And C complement, try D, CD. Join and meet, both will fail to reach upper bound and lower bound. Fails. C complement E, CE. Join and meet, both are there in the C and E. Fails. C complement is F. F. Join is fine, but meet is the C. So meet fails. And C complement not exist. Similarly, D complement. E complement is a B, F complement is A. This is not a complemented lattice. But when the complement not exists, you should be very careful. And this is not a complemented lattice even though it is bounded lattice. Now I'm going to explain the last concept today, distributive lattice. What is distributive lattice? Okay, I'm just theoretically saying distributive lattice means it is bounded lattice where each element has at most one complement. At most one. At most one means either no complement. If you have a complement, it is unique. If complement exists, it must be unique. If complement exists, not exists, fine. But if complement exists, it must be unique. Means only one. You can't have more than one complement. You can have 0 or 1. This is distributive lattice. You look at it, C and D 0 complements, remaining are exactly 1. It is distributive. Clear this point? It is distributive lattice. Okay, so there is a property. In case any lattice satisfies distributive and complemented lattice. If we satisfy both of them, a lattice which is both distributive and complemented lattice, then it is going to be Boolean lattice. Why is that? Because every element will have exactly one complement. In that case, you will satisfy every property. Every element has exactly one complement. If you satisfy both, complemented says every element should have a complement. Distributive says if complement exists, it must be unique. If you want to satisfy both of them, every element will have exactly one complement. Okay, so I hope I revised the lattice theory, which is important for you, and also we have covered group theory and so many things. And next session tomorrow, propositional predicate, right? If I am not able to teach any concept, please watch the videos where we have covered. So these are already covered every topic in detail, and it is available in playlist. You can watch it. And today we have completed relations and then functions. What's happening? Group theory and lattice theory, and yeah. Thank you so much for joining today. And in case if you want to know about the subscription, plus is the structured courses where you will have live interactive classes, and you will have weekly test doubt solving sessions, and you will have batches for both separately English and Hindi. So this is going to be much benefited for those people who are seriously preparing for GATE. And Iconic, all benefits of plus. Additionally, you will have personal coach. Also you will have personal interaction to clear your doubts with every educator. That's going to be fun for you. And this is the batch which is started on 18th Jan. So if you want to join, let me know, and you may use my referral code in case if you want to join. And if you want to know the prices, you can see that plus we have 3 plans I am showing here, but many other plans are there like 1 month, 3 months, 6 months. If you go for 2 years, 39,600 after applying my referral code. Even Iconic also having many plans, but I am showing you for 1 year and 2 years. Here for 2 years, 66,600. And this is my profile, where if you want to follow my classes, please visit unacademy.com/DEVAGATE and click on follow button so that you can get the notifications of my classes. Yeah, this is a Telegram channel. If anybody not subscribed to this Telegram channel, please subscribe to this so that our material will be shared on this channel. So please do that. And we have so many free YouTube channels from Unacademy. You can watch, and if you have any friends, you can refer these channels so that they can subscribe. And thank you so much for joining today. Yeah, bye bye, take care. If anything is not covered, we will cover in practice session. You know how practice session will be there.